What if the cutting-edge cloud solution everyone's talking about is actually hiding a significant cost? We're exploring the surprising challenges of custom ARM chips in the cloud, and why one major player suggests they are not always the magic bullet you might think. For years, the biggest names in cloud computing, the hyperscalers, have been quietly designing their own custom ARM server chips. They're built by manufacturing giants like TSMC, and on the surface, it makes perfect sense. These chips promise efficiency and bespoke performance. But AMD, a company that knows a thing or two about server processors, wants us to take a closer look, especially if you are navigating the complex world of hybrid cloud or trying to avoid vendor lock-in. We recently sat down with Madhu Rangarajan, AMD's corporate vice president of product management and planning for their server solutions group. Madhu is no newcomer to this space. He spent decades at powerhouses like Dell and Intel, and even served as VP of products at ARM server CPU specialist Ampere Computing, which SoftBank is now in the process of acquiring for billions. So, when Madhu talks about server chips, you listen. He argues that while ARM has finally carved out a significant share of the server CPU market over the last decade and a half, the way it has happened has actually created as many problems as it solved. The first big issue Madhu points out is fragmentation. When you look at ARM instances across different cloud providers, they are not all built the same. They use varying instruction sets, different core types, distinct cache hierarchies, and even target different frequencies. Think of it like this. If x86 chips offer a universal language across the cloud, these ARM implementations are more like a dozen different dialects. This forces you to optimize your applications for each specific ARM setup, which completely erases the universal substrate advantage that x86 provides. Madhu puts it bluntly. What's the cost of fragmenting the fleet? He asks you to consider your multi-cloud strategy. If you go down this fragmented path, what does that do to your pricing and long-term costs? What about your on-premise hybrid cloud strategy? Does this diversity enable seamless hybrid operations? Because ultimately, that low instance cost you see up front, it's often just a small percentage of your overall budget when you factor in the massive hidden expenses of porting, testing, and validating your software across all those different ARM implementations. And here is another critical point. Aside from Ampere Computing, a true enterprise-grade ARM CPU for your on-premises data center is largely absent. Sure, NVIDIA is selling its Grace CPUs for AI clusters, but those are very different beasts than the homegrown ARM chips cloud builders craft. This means a truly unified, consistent computing substrate that spans your on-premise infrastructure, and your cloud infrastructure becomes incredibly difficult to achieve with ARM. To top it off, many enterprises still run a significant number of applications on Microsoft Windows Server, and current ARM instances simply do not support Windows Server. They only run various flavors of Linux. By contrast, AMD emphasizes that all the major cloud providers and hyperscalers use AMD EPYC processors in their fleets. Major hardware makers also build machines using AMD EPYC CPUs for on-premises use. This consistency provides that universal computing substrate you need, simplifying compute across your hybrid cloud architecture and significantly reducing complexity. So, while the initial price tag of an ARM instance might catch your eye, AMD wants you to look much deeper than that. It's not just about raw cost. It's about the true price of complexity, flexibility, and vendor lock-in. It's about ensuring your infrastructure strategy truly works for you, both today and tomorrow. What are your thoughts on cloud fragmentation? Have you encountered these hidden costs? We would love to hear from you. Make sure you subscribe to our podcast to catch more insights just like this.